So in the last video, we had covered the topics of factorials and index of the greatest power of a number, right? So this is the last topic of number systems module wherein we'll be covering the base systems. So base systems is nothing but a method of representation, okay? And different base systems signify how many symbols we will be using for denoting a number. For example, in the decimal base system, we use 10 symbols for signifying any digit, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it is a representation method uh, of decimal number system. This is the most commonly used and it is understood by anyone and everyone. But there are different base systems as well, which are used at different places. Like they have a specific use case for them, right? So talking about the definition, so a base is a number which decides the place value of a symbol or a digit in a number. So see, if the base is equal to 10, which is in the case of decimal number systems, so we will be using a total of 10 symbols for depicting a number. Had this number been greater than or lesser than 10, then we would have used less or greater number symbols respectively. Okay. And it is also the number of distinct symbols that are used in that number. Yes, as already said. Now, what are the symbols that are used? Digits 0 to 9, we all. But alphabets A to Z are also used over here, wherein A is equal to 10, B is equal to 11, C is equal to 12, and it goes so on up till Z is equal to 35. Okay. So these alphabets are also used for depicting a number. So the standard one is the decimal number system, and this is how it goes. Now, there are certain types of number systems. So one of them is binary number system. With base is equal to 2. So we will be using only two symbols here, which are 0 and 1. So see, decimal to binary. How can we do it? So let us say decimal is 0. So binary is also 0. 1, 1, then 2, 1, 0, 3, 1, 1, 4, 1, 0, 0 in binary. Now how it is done? See, in decimal, if we say the number 3, 4, 6, then it is equal to 3 into 10 to the power 2 plus 4 into 10 to the power 1 plus 6 into 10 to the power 0. And that is why we write it as 346. Now, if this number had to be written in the binary form, so we will have to write it in the form of 2 to the power 0 plus 2 to the power 1 into plus 2 to the power 2 plus so on plus up to 2 to the power 8 because 256 is less than it. So 346 is equal to 1 into 2 to the power 8 plus 90 is left. So 90 is not divided by 128. So 0 into 2 to the power 7 plus 2 to the power 6. So I'll just erase it off for a moment. 0 into 2 to the power, okay. 2 to the power 6 is 64. So yes, 1 into 2 to the power 6. So 90 minus 64. What is left? 26. 26 not done by 32. So 0 into 2 to the power 5 plus 2 to the power 4. Yes. So 16 into 1, which is 2 to the power 4. Plus what is left? 10. 10 can be subtracted from 8 into 2 to the power 3. 1 into 2 to the power 3. Plus 0 into 2 to the power 2 plus 1 into 2 plus 0 into 2 to the power 0. So the number essentially is 10101110 in base 2 is equal to 346 in the base 10. So this is how it is written. 346 in base 10 equals to 10101110 in base 2. So this is how you can do the decimal to another conversion. Okay. Now we will look at binary addition and subtraction. So let us say we are given two numbers 1101 and 1001. Okay. So when you do the addition, so in the decimal, what you did was if the sum of the digits is greater than 10, then you would have one carried in decimal. So in binary, what we will do is if sum is equal to 2, so you place a 0 here and add a carry of 1. Now 001 sum is 1. 10 sum is 1. 11 sum is 10. So this number is 10110 and its representation in decimal form will be equal to 2 plus 4, 6, 6 plus 16, 22 in base 10. Okay. So this is how you do the addition. Now, in case of subtraction, let us say 10110100 and you have the number 101110. You have to do this subtraction. So in decimal system, what you did, if the upper digit is lesser than lower digit, then you added a 1 in front to make it 10, right? But you will make it 2 in this case. So 0 minus 0 is 0. Then 0 minus 1. Here you will have a 1 and this will convert into a 0. Now 0 minus 1. So again you will have to make it 0. So 0 minus 1, it is 1. Then here we made it 1. So 1 minus 1, 0. Then again 1 minus 1, 0. And okay, so there is a problem. You carried 1 here. So you will have to carry 1 from front as well. So this 1 will convert in a 0, 1. And 1 minus 0, this will be 1. Okay. So this was made as 1. So this was also converted in a 0. So here 1 minus 1. Here we will have a 1, then a 0. And then for this digit minus this digit. So you will have to carry 1 here. So this will be 0. This will be 1 and this will be 0. So here you will have 2 minus 1, which is 1, then 0 and 0. So this number will be 10110, which is again 22 to the base 10. And if you will convert these numbers in decimal form, you will get the answer as 22 only. So this is how binary addition and subtraction is done. And lastly, the naming convention for different base systems is like this. So base 2 is called binary, base 3 ternary, base 4 quaternary, and so on. So you can have these names in your mind. So if any question includes this number system convention, so you will be able to solve it accordingly. So that is pretty much it from this particular video, as well as this particular module of number systems, wherein we have covered all the topics that have been asked and that are in the syllabus of number systems.